Hi everyone, I hope it's going okay. We're going to look at a specific type of sequence today called arithmetic sequences. Not arithmetic sequences, but arithmetic sequences. Before we do that, let's do a little warm up from last class. So you can try this out if you want, press pause, then check your answer. So remember, this is all about notation, this stuff. So we're trying to find the first three terms in the sequence, and we've got the general term or the algorithm to create the sequence based on this t sub n, and we've got the first term is 4. So we can start with the second term then. So I put in t sub 2 for the second term, and I sub in wherever I see n, I sub in 2. So I get this. Notice this is a unique sequence in that it's got n as part of the calculation and also part of the term number here. So if I do this and I simplify, this becomes 2 times t sub 1 minus 5 times 1. And so this is where we need to replace t sub 1 with t sub 4. So the thing I'm going to put in there is the value of the first term, which is 4. And so I have that, minus 5. And so I have 8 minus 5. So this is going to be 3. So my second term's value is 3. So the next one, the third term, do the same thing. So try this out. You can jump a couple steps in this process if you want. So the key here is that at this step, I'm going to replace t sub 2 with the value of t sub 2, which is, we found here, to be 3. So let me just highlight that. So this guy is the 3. So I have 2 times 3 minus 10. So this is going to be minus 4. So that's the value of my third term. So some sequences can be complex and have all these n's everywhere in order to create the sequence. Don't worry, you're not going to have to come up with that formula, but you should be able to apply the formula just like we did here. Okay, so as mentioned, we're going to look at specific types of sequences, and there's really two major types of sequences. One is arithmetic and the other is geometric. And the arithmetic, if I look at this example here, you may have heard of this famous comet called Halley's Comet. If not, it was discovered by this guy in 1705, Sir Edmund Halley, and he looked back on celestial records that went back to 2039 BC. And of course, there was a pattern within this. And so he saw this pattern that something appeared in the sky for a couple nights, all the way back, and it was predictable, all the way back a couple thousand years. And so what he found was there was a difference of about 76 years. It was in fact about 75 point something, so this is slightly off, but you get the idea. So he predicted when the comet would appear again. Unfortunately, he was dead by the time it happened, but all he did obviously was add a difference, a common difference here. And so he predicted it would come back in 1759. And it did. And then it continued to come back. And so they named this comet after him. And if I keep adding these on, I think it was 1911. And then I was actually alive the last time it came, which was in 1986, but I'm going to put 87 here just because I was adding 76. And so it was a pretty unique thing in time in that everyone went outside in order to look at this comet. I remember we went up in the hills by my house in order to look at this comet. And it was pretty special, I remember, just because everyone was doing it. It's kind of like at the moment right now, how everybody's doing the same thing. So if you look at this GIF here, if you look at the white part, it's hard to see perhaps, but that is the orbiting comet of Halley's Comet. And so it's really quick when it gets close to the sun. So in the middle is the sun, obviously. I don't know what all these other things are rotating, but we're really close to the sun. And so hopefully you'll be alive by the next time it comes, which if we add another 76 years, I believe it's going to be 19 1963. And it might be 1962 because, again, I think it's 75 point something. So hopefully you'll be alive. Perhaps I will be, but who knows. So anyway, this is an example of when you have something that's separated, a pattern that's separated by what's called a common difference. And so in an arithmetic sequence, it's just a pattern where you have this constant that's being added or subtracted. And we call that thing the common difference. And because of that, it's going to have the value of a d, so the difference. So if we look at these three examples here, it says, which of the following are arithmetic sequences? So generally, it's pretty easy to spot these. So the first one here, I'm adding 2 to each of my terms. So yeah, this is arithmetic. The second one, if you look at the pattern overall, I'm not adding 2, but I'm multiplying 2. So this is not arithmetic. But it does fit into a pattern, and it is what we call geometric, which we're going to look at next class. And so the next one's not so obvious. And when it's not obvious, what you can do is, if you think of the first one we looked at here, all we did to get this common difference was take consecutive terms and subtract them. So like 6 minus 4 equals 2, 4 minus 2 equals 2. So in this case, if I take t2 minus t1, so let's try that. So t2 is 2x plus 5 minus all of term 1. What I'm looking for is what the common difference is, d. So if I do that, I subtract this, so I get 2x plus 5 minus x minus 2, which becomes 2x minus x is x, 5 minus 2 is 3. So what I want to do is see, is it a common difference with the next one? So I take the next two consecutive terms, t3 minus t2. And I'll do this one a bit quicker. Again, applying the negative to both, and what I find is that yes, it is a common difference of x plus 3. So therefore, this is arithmetic. And so most of the time it's pretty obvious if it is. If it's not, you can just take consecutive terms and make sure they have the same difference. So what's nice about categorizing these kinds of sequences is that once you know if it's arithmetic, you can then apply something that's a formula that makes it much, much easier. So if we take a sequence that's arithmetic, let's say the initial term we call a. So the first term's value is a. If I add d to it, a common difference, then I get this pattern where I'm just getting consecutive d's and adding more. And so what happens is I get a general term where I have the initial term plus n minus 1 to get rid of the d from the first term. And this is the general formula for an arithmetic sequence. And so you can always just rely on this thing. That's what's so great. And so in this, a is my initial term, or my first term, whatever you want to call it. D, we said, is my common difference. And n is my term number. And t sub n is the general term or the value of the nth term. So you're going to know that formula pretty well, but of course you will always be given that formula. So let's try to apply it. So if I look here, it says determine t sub n, which is the general formula, and then the ninth term for each sequence. So in this sequence, we have to write down and think about what we know. So my first term, a, is just minus 10. What is my common difference as I'm going through? So this is pretty easy to see that it's plus 4. So I say my d value is 4. So that allows us to set this up using the general formula. So I'm going to write it out again. And I sub in what I know. So I've got t sub n equals a, which is negative 10. N we're not putting in and then d is 4. So what I need to do, I should expand this or simplify it. So I'm going to expand and distribute the 4 in. So I end up with negative 10 plus 4n minus 4. And then I can collect like terms. So my general term is going to be negative 10 minus 4 gives me negative 14 plus 4n. So that's a formula that's going to calculate any term within this specific sequence. So they ask us to do it for the 9th term. So for the 9th term, I just simply sub in 9 for n. So I end up with t sub 9 equals 36 minus 14, which is 22. So my 9th term's value is 22. So why don't you try the next one out and see if you can get it. So just apply that formula. So again, press pause and then you can fast forward through. So this one I've got minus 8 each time. A is 40. So I can sub this in. You don't need to write out the general formula every time if you don't want. I'm putting my negative 8 in brackets like that because I don't want it to look like just minus 8 or subtracting 8. So if I simplify this, I end up with 48 minus 8n. So that's my general term. So now I can get my 9th term. So my 9th term is going to be a negative value, which is negative 24. Okay, so not too bad. Other things we can do, let's say we've got a sequence that actually ends at some point. So rather than count up all the terms that go to that endpoint, what we can do is use this formula that we had in order to get that the value or the number of terms that get to 150. So we use the same stuff. So A is negative 10. In this case, D is going to be plus 4. So just make sure it's the same for each of them, which it is. And so we've got that. The other thing we know is the value of the last term. So T sub n's value is 150. What we want is what is n, the term number. So if again, we sub everything in, so I'm going to write out the formula just so you see it this one time to write out, and then you put in 150 for T sub n. And we leave n, as n, because we don't know it, but D is 4. So I can figure this stuff out. So a little algebra. And so I get minus 14, I'm going to add that over, so this becomes 164 equals 4n. So therefore, n equals 41. So therefore, there are 41 terms. Or the 150 is the 41st term. So try this one out, see if you get it. Again, you can skip through if you want. So my common difference is negative 8. My A is 40. And T sub n is negative 48. So I'm just going to jump right in. So I got negative 48 equals A plus n minus 1 times negative 8. I need to distribute that in. So this, I'm going to add it over. So this is negative 88 equals negative 8n plus 8. Doesn't matter if you do it the other way I did the other one. So this becomes negative 96 equals negative 8n. So therefore n is 12. So we've got, there are 12 terms. Great. So not too bad. So a couple other things we can do with this. We can find the term and the common difference. So let's say we know two terms in the sequence. So this one says determine the formula for the general term T sub n in an arithmetic sequence. So we need to know that with this and this. So I've got the 3rd and 7th. So you probably could kind of figure out the difference between the two. We know there's 4 terms. You might be able to figure out that way. But I'm going to show a way that's always going to work because sometimes it can be tricky to do it the other way. So I know that t sub 3 equals this. What I don't know is d and a, but I know the value of the third term is 35. So I'm going to put that in, and I know that it is the third term, so n is 3. And I leave d as that. So I can simplify this slightly. So this becomes 2d. I'm going to call that, well, I'll come back to it in a second. And so the next one, I've got t sub 7. If you want, you can just jump straight in. So t sub 7 is 55 plus 7 minus 1. So 55 equals a plus 6d. So what we have right now are two equations, and we have an a and a d, so we have two unknowns. I'm going to call this equation 1 and this equation 2. So I'm going to do 2 minus 1. So I'm going to subtract equation 1 from 2. How you write that is up to you. I'm just going to put minus and everything in brackets. And so that this becomes 20, a minus a is gone. 6d minus 2d becomes 4d. So therefore d equals 5. So you can sub this into either equation. I'm going to sub it into 1 because they're smaller numbers. And we work this out. So a equals 25. So my first term's value is 25. So the only thing we have to do is just write this in as a general formula. And I can simplify it. Like that. So there's my general term. Okay, why don't you try the you try part out? I'll put in the